Hello friends, welcome back to my YouTube channel. Now we'll discuss the Kptcl AE paper. The question 40 is a continuation of the previous video lectures. A toy is in the shape of a right circular cylinder with hemisphere on one end and one cone on other. The height and radius of the cylinder part are 13 centimeters and 5 centimeters respectively. The radii of this hemisphere and the conical part are the same as that of the cylindrical part. Calculate the surface area of the toy if the height of the conical part is 12 centimeters. Now here a toy is in the shape of a right circular cylinder. So right, let me take here right circular cylinder like this. Okay, right circular cylinder with hemisphere on one end, here, and cone on other end. So cone is here like this. Okay, so cone is on other hand like this, right? Now the height and radius of the cylinder are, so height of this one is, it is how much, 13 centimeter, and the radius is how much, it is 5 centimeter. Okay, now the radius of the hemisphere and the canonical parts are the same, so this is also same here. Same means 5 centimeters here also 5 centimeters. Now I'll calculate the surface area. So to find here, let's give a notation. First here it is, let's hit the point O, and here is the center, here it is A, and here it is center point, here it is a B, and C here, and D here. So from the triangle OAD, from this triangle OAD, we can write it as OD square is equal to AD square plus OA square. So OA is distance given if the height of the canonical part is 12 centimeters. So 12 square plus OD already 5 square is nothing but 169. So OD can be written as 13 centimeters. Okay, next one. Next here the total surface you need to find. So total surface area of toy is equal to the curved area of the cone, so I'll write the formula here. So curved area of cone into plus, so here it is a plus. Next one, curved area of the cylinder, plus curved area of the hemisphere, so from this we can write, so curved area of this cone is nothing but pi r into O into D. Okay, in plus, now curved area of the cone curved area of the cylinder, so curved area is 2 pi r into A into B, so distance here. Okay, plus 2 pi r square. So from this, pi r is nothing but 22 by 7 into radius is how much, 5, and OD is 13 plus 2 into pi means 22 by 7 into AB. So AB is how much, 2 pi r 5 into AB is 13 plus next one, it is 2 into this 2 pi r square, 2 into 22 by 7 into r square means 5 square. So if you calculate this, that is 770 centimeter square, 770 centimeter square. So option D is the right option for this question. Okay, we'll move to the next question here. Okay, now here in the circuit given below, find the current through the inductor is. So here we need to find the inductor. So let's give the notations here. So here we have minus sign, it is plus sign, and here we have plus, and here minus. So they all are one voltage at an angle 0 degrees, and here we need to find the voltage, and here we find the current. So I need to find the current flowing through the inductor. The basic formula is current flowing through the inductor is equal to voltage across the inductor divided by impedance is given as J1 ohm. Okay, J1. So this is a GATE 2012 EC question. Okay, so this is a repeated question here from the GATE examination point of view. GATE exam. Now IL is equal to VL by J omega into 1. So here we need to find the VL. So for that, assume that there is a voltage. Here it is V. Assume that voltage. Now apply nodal analysis here. So by nodal analysis, what you can write? V minus of minus 1 here, 1 volt here, divided by how much resistance? 1 plus V. Assume that it's a ground potential. Sorry, it's a ground potential here with respect to this. So current entering here it is minus 1. So here we have minus 1. So minus 1 here, and now here plus V minus of minus 1 divided by J1 is equal to 0. So by solving this equation, we will get V as V is equal to minus 1 by J plus 1. Okay, now we want VL here, voltage across the inductor. So if you apply KVL in this loop here, the KVL in this loop, if you apply KVL, already we know this value is V. So plus or minus V here. So minus V plus here it is VL, and here there is a 1 voltage here, so VL, and this is a minus plus here. So we can write minus 1 is equal to 0. So from this VL is equal to V plus 1. So what is the VL you get? It is, so VL is equal to, from this calculation you can get J divided by J plus 1. But what we want the current. So IL, from this formula, IL is equal to VL is J divided by J plus 1 into 1 by J1. So J1 gets cancelled here. Final answer will be 1 by J plus 1 is the right answer. So answer is here, it is C is the right option. D is a wrong option here. Okay, so check this answer, it's a wrong. Okay, for this bit. Next question. XYZ is an oil-based business company which does not have adequate working capital. It fails to meet its current obligations, which leads to bankruptcy. Identify the type of decision involved to prevent the risk of bankruptcy is investment decision. So right answer is investment decisions. Next we'll focus on this question here, which is electrical question here. Now, so this question can be written like this. It is, so here we have 9 kilo ohm and 1 kilo ohm here. I'll take this network like this. So 9 kilo ohm, 1 kilo ohm. If you add these two together, it will be how much? 10 kilo ohm. Now it is in parallel with how much resistance? 100. Now there is a current source going upwards like this. It is 99 IB, and the current flowing is 1 kilo ohm. It is like this IB. Now, so this is a given network. In order to find the resistance, when you are looking from these two terminals, you need to find the impedance here. So I need to find Z12 here. Terminals are 1 and 2 here. So to do so, we'll assume that there is a current source and with a voltage source here. So I'll take a VOC, which is going to supply a current of 1 ampere. That assumption I'm making. Now Z12 will be, so VOC by 1. So it's nothing but whatever the value you get, VOC, same answer you get here. Now here the current entering here is IB. Now current entering is 1. So if you apply 1 ampere here, and how much current flow here? So 99 IB plus 1 is the current flowing in this branch. Now this store entering here, how much current will flow here? It is, so it is 99 IB plus IB means 100 IB plus 1, the current flowing here. Now all these are in parallel connected system. So all these are in parallel. So if all are in parallel means voltage will be same. So VOC here, but the current entering is reverse relation. So plus minus here. So I can write my VOC is equal to minus 10K into IB. And similarly here, if we apply same voltage rule, VOC is equal to current is flowing, so plus value. So 100 into 100 IB plus 1. So if we solve this VOC, we will get that IB value as, so by equating these equations 1 and 2, if we equate these two equations, now IB value which will be getting as minus 1 by 200. Now we want VOC value to find this. So VOC is nothing but VOC can be nothing but anything you can take here. It has IB. So here 10 kilo, that means 10,000 into IB value is, okay, it is 1 by 200 now. So by 200 here. So IB value we got here, VOC I'm substituting here. So minus he'll get into minus will get here. So substituting this for this value here. So substituting IB value into this value, and we are writing this equation here. So from this we can get it as 50 volts, sorry, 50 volts. Now Z12 is how much? 50 volts divided by 1 ampere is nothing but 50 ohms. So among the options, A is the right option for this question and A is the correct option here. Next question from the DC machines. In a DC machine, the armature MMF is, rotating with respect to field. So it is stationary with respect to field poles but rotating with respect to armature here. Okay, next question here, 45th question. Inverse definite minimum time lag relay is also called as, overcurrent relay. It is not the differential relay. Inverse definite minimum time lag relay is also called as overcurrent relay. Next question here. So this is a problem which is repeated in the earlier videos. You can check it again. So it is the same repeated problem. So in this paper, almost 5 to 6 questions are repeated again and again. Okay, so next question here. Next question. A high pass pi connected symmetrical filter section has a capacitance of 500 picofarads in series arm and inductance of 500 microhenry in each of its shunt arms. The cutoff frequency of the filter is, so here the basic formula is F is equal to 1 by 4 pi square root of L into C. Okay, now here what is the question they asked here? It is a 5000 microfarads in series arm, means here the filter is looks like this. So 5000 picofarads here, and the capacitor is here, here inductor shunt arms, how much it is here? It is 500 microhenry. So 500 microhenry, and here also 500 microhenry, right? Okay, now so the equivalent circuit, the formula which you are using here, what is the meaning of L means here? So it is going to be L. So here L value is, this is as per the formula, it is 2L here and this is 2L. So if the value of 2L is 500 microhenry and L value is 250 microhenry. Now substitute the value here, 1 by 4 pi, here L value is not 500, it is 250 into 10 power minus 6 into C value is 5000 into 10 power minus 12. So if we solve it by using calculator, we will get the answer as 71.2 kilo Hz is the answer. So D is the right answer for this question here. We will move to next question. Now 48th question here. The stationary alternator should not be connected to the live bus bar because it will get a short circuit. Why? Because stationary alternator means there is no energy conversion. So the stationary alternator is going to act as a short circuited winding. So we'll get a short circuit here. Next one, 14th question. The maximum power in a cylindrical and a silent pole machine is obtained by respectively by, meaning maximum power in cylindrical and silent pole. So cylindrical it is 90 degrees. In silent pole it is going to be less than 90 degrees. As we have seen in our previous discussion, the answer is C here. Okay. So thank you friends. Thanks for watching my video. We will continue this lecture series in the next coming sessions. And if you like my video, please subscribe and share. And those who are not subscribed till now, please make a subscription and press the bell icon button to get updated videos here. Thank you. Have a nice day.